So this is a question which is related to star to delta connection. Okay, we have discussed, I think, 2 or 3 questions related to star to delta transformation concept. So this is the third or fourth question, I think. Okay, so here we have been given a circuit which is connected to a DC voltage source of 10 volt, and we have to determine the circuit current I. Okay, so here we are going to use or apply the star to delta transformation concept or delta to star transformation concept to simplify the circuit and find the circuit current I. Now, if you look at this combination or connection of resistors, suppose you try to solve it without using the star to delta or delta to star transformation concept, then it will be very difficult to do that, because you cannot identify which resistors are in series connection, which resistors are in parallel connection. You will not be able to begin, you will not be able to find a point where you can start solving the circuit. So you have to use the star to delta or delta to star transformation concept to simplify the circuit. Okay, now where to apply the delta to star transformation concept? Look at this connection of resistors. This connection of resistors. You can see a pi shaped structure or a pi shaped structure here. If we combine these 2 points, then it will become a delta shaped structure. Okay, I am talking about this 2 ohm, 3 ohm and 2 ohm connection. Okay, let us draw it separately. This 2 ohm, this 3 ohm and this 2 ohm. This is a pi shaped structure. This is a pi shape. Now let us just convert it into a delta shape. Okay, so it can be converted into a delta shape. Okay, we are using the delta to star transformation concept. So this is 3 ohm, this is 2 ohm and this is 2 ohm. Okay, so now it converted into a proper delta shape. Let us just name this points 1, 2 and 3. Now we will try to find its equivalent star shaped structure. Okay, so let us do that. For that, this will be R1, this will be R2 and this will be R3. This will be R1 because it is connected to point 1, this is R2 and this is, let's say, R3. Now we know the delta to star conversion formula. The value of R1 is equal to, we have to include all the resistances in the delta shaped connection which have point 1 in common. Okay, this point 1 in common. So here it is R12 and R13 or R31. Okay, R12 into R31, and the denominator will remain the same in each of the 3 resistance calculation, that is R12 plus R23 plus R31. So here it is, R12 is 2 ohm, 2, R12 is 2 ohm, R31 is 2 ohm by 2 plus 2 plus 3, 2 plus 2 plus 3 is equal to 4 by 7. Okay, 4 by 7 ohm. So let us just convert it into decimal form. Okay, Let us just convert it into decimal form. 4 divided by 7 equals to 0.57 ohm. This is 0.57 ohm, sorry, 0.57 ohm. Okay, let us just write it down here. R1 is equal to 0.57 ohm. Now, let us calculate R2. R2, for that we have to include all those resistances in the numerator which have 0.2 in common. That will be R12 and R23. Okay, R12 and R23, the denominator will be the same. It will remain constant throughout. So R12 is 2 and R23 is 3. So that will be 6 by 7. And 6 by 7 is equal to, let's say, just calculate 6 divided by 7, 0.85. 0.857 actually, 0.857 ohms. Okay, so let us just write it down here. R2 is equal to 0.857 ohms. Next we have to calculate R3. So for calculation of R3 we have to include all those resistances in the numerator which have 0.3 in common. So here already R23 is present, we have to include R31. Okay, so R23 is equal to 3 and R31 is 2. So the same because R31 is 2 and R23 is 3, so same, 6 by 7 will be 0.857 ohm. So R3 will also be 0.857 ohm. Okay, so we just find out the equivalent star shaped network. Now let us just redraw this circuit. Okay, so how we can do that? So here we will change it here only. Okay, let us just do this. So just remove this portion. Okay, so it is R1, this is here, this is here. R1 is equal to 0.57 ohm, R1. This is here R2 is equal to 0.857 ohm, and this R3 here is also equal to 0.857 ohm. Okay, so now just simplify this circuit. So now this circuit can be redrawn as we are just including the resistance part. Okay, this is 1 ohm. With that we have R1 which is equal to 0.57 ohm. Then we have R2, that is 0.857 ohm. We have this 2 ohm. We have this 0.857 ohm, and we have this 2 ohm. Okay, this. Now we have to find out the equivalent inductance of this resistance combination. So you can see this 1 ohm and 0.57 ohm, they are in series because there is a end-to-end connection pattern. So we can just combine it into 1. Okay, so this will be 1.57 ohm, 1.57 0.857 ohm. This 0.857 ohm and 2 ohm, they are in series. This 0.857 ohm and 2 ohm, they are in series. So we can just combine them into one resistance in both the terminals. This will be 2.857 ohm and this is also 2.857 ohms. We are just considering this resistance portion. Okay. Now this two 2.857 ohm resistances, they are in parallel. So the equivalent resistance of this combination will be 2.857 into 2.857 by 2.857 plus 2.857. So let us just calculate it. 2.57 by 0.57 plus is equal to 1.4285 ohm. Okay, 1.4285 ohms. So if we just rub this and replace it with its equivalent resistance, it will be, so this is nearly equal to 1.43 ohms. 1.43 ohms. So this will be 1.43 ohms, the equivalent resistance. Now this 1.57 ohm and this 1.43 ohm, they are in series connection. Okay, they are connected in series. So the total resistance, the equivalent resistance of this whole combination will be the addition of these two resistance values, which is 3 ohm. Okay, which is 3 ohm. The total equivalent resistance is equal to 3 ohm. Now this total resistance is connected across 10 volt. So the circuit current I, okay, so the total equivalent resistance we calculated, which is 3 ohm. Now we have to find out the circuit current. We know current is equal to applied voltage by total resistance, which will be around 3.33 amperes. Okay, 10 by 3 amperes or 3.33 amperes, which is the total circuit current. So here the question was to determine the total circuit current, but we had to use the star to delta or delta to star transformation concept to simplify this resistive circuit, the combination, the groups of resistors which were connected. We had to use the delta to star transformation concept to simplify the circuit so as to easily calculate the equivalent resistance, which we calculated as 3 ohm, and then we calculated the total circuit current. So here the finding of the current, it was easy, but the tricky part was to calculate the equivalent resistance. So for that we had to use the delta to star transformation concept. So this is, I think, the third or fourth question which is related to delta to star transformation concept which we have studied. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.